Okay, this is just a very quick video with a few examples for our sequences, next level sequences. So these synchronous sequences are better because we can define what the output is going to be, and the reason for that is because we use logic gates to create the next input. We don't just rely on them actually just counting up. We force them into different states, and you can tell which ones are which because all the clocks are connected together, which avoids a ripple effect that you get from the binary counters where one has to the value has to ripple through the counter, and so on and so forth. So we've got our first example here, and that first example has we're going to look at how just drawing the sequence. So first of all, for drawing the sequence, that's our current state 0. There we go. So we've got 1 0 0, and that's state 0. That's starting off there. Then that feeds round to that goes on to 0 0 0, which comes in onto this next line here. So that's telling us what we've got next, and then we put it on the next line there. So we've got state 1, which is 0 0 0. So we can go up in any order. Then from there we go to 1 1 1. Okay, we go to 1 1 1, and we should see that 1 1 1 is state 2. That goes on to here to 0 1 1, which is state 3. State 3. What did I say? 0 1 1, like so. And state 3 feeds to 1 0 0. Well, we can see that 1 0 0 is state 0. So then that goes back round to there. So that's how our sequencer goes round. So this is our main sequence. That's our main sequence. So we've got some other bits and bobs here. So let's have a look what we've got of our other bits and bobs. So we've got 0 0 1 that goes to 0 0 1. So it goes to itself. So 0 0 1, which is state 4, just goes to there. So that is what's called a stuck state. That's a stuck state that never joins the main sequence. Okay, so that's stuck, and let's have a look at what we've got here. So then we've got 0 0 1 0, so 0 1 0, which is state 5. Okay, that is feeding into 1 1 0, state 6. Okay, so that's okay, that's all right. We're all right so far. It's, one unused state can feed into another, and that feeds then into, and 1 1 0, state 6, feeds into 1 1 1. So actually, so those unused states, they're not part of the main sequence. So unused states are not part of the main sequence, but we certainly want them to feed into the main sequence. So there's only one last state that we've got, state 7, that we haven't looked at. So 1 0 1, and that goes into 1 0 0. So we've got going into there state 7, 1 0 1, and that's as drawing a diagram to show what's going on with this sequencer. Okay, moving on, we've got this diagram here. So this is a given sequencer, so we might want to work out what the Boolean algebra that's making each of the output states. So if we start with DC to start with, so the data input for C, that's an AND gate, but that AND gate is made up of coming from A and B. DB, we've got an input here from flip-flop C, but it's coming from the not Q output. So that's the equivalent of saying not C. not C. And then we've got it's an OR gate, and then the other input into the OR gate is coming from A. And then finally DA, it's a NAND gate there, but we've got an input back from itself from flip-flop A itself. It's coming from the NOT queue, so that's the equivalent of saying NOT A. And B and C, and so that fulfills that part of it, and then we've got to do the overall NOT there. So that's how we put together the come up with the Boolean expressions. A lot of this stuff on the sequences is about Boolean algebra and logic gates. Okay, so if we're given the Boolean algebra, we might have to produce the table. So how do we produce the table? So given a starting position, we've got DC here is not B. So not B, so it's a 0, so that would be a 1. We've got the exclusive OR of A and C. Well, they're not different, so we've got a 0. And we've got we've got B nor C. So what have we got there? So they're both zeros, so that must make that a 1. So that then forms our next state, like so, hopefully, if it all goes well. And we then do DC again. Well, DC is not B, so that's still a 1. DB is exclusive OR of A and C, so that's a 0 again. And we've got BC, that's a 0. So that forms on into the next state there. Okay. I'll just do the next line slowly, and then I'll just rapidly fill in the table. So DC is not B again, so that's still a 1. And DB is exclusive OR of A and C, so that is a 1 this time. And then BC, that's a 0. So we've got 1, 1, 0 going there, 0, 1, 0, 0, 1, 0, 0, 0, 0, oh, 0, 0, 0. So that hopefully is our main sequence. And what else have we got left? So just very, very quickly filling in these next lines. So we haven't, that one hasn't been, 1 hasn't been used, 3 hasn't been looked at, and equivalent of 7 hasn't been looked at. So we've just got to look at the states that haven't been the values that we haven't seen, and see where they go to. So this one goes to that. That goes to that, and that goes to that. And then if we look at all of them, are any of them, are they unused, or are they just stuck? So we've got that goes into the to 1, 1, 1. 1, 1, 1 goes to 0, 0, 0, so that's okay. So that's into the main sequence, into the main sequence, and 0, 1, 1 goes into 0, 1, 0. And 0, 1, 0 state 4 there, so that's okay. That goes back into the main sequence. So they're all unused, so that's fine. We've got no stuck states. Got no stuck states in this. Okay, so how do we come up with the logic then? So if this is a table that we've got, then we go down and fill in for DC depending on what we've got here. So this one should be a nice straightforward one for us to do. So we've got 2 zeros there, so let me fill my zeros in on here. So I've got a 0 when I've got 1, 0, 1. So 1, 0, 1, I'm going to have a 0 there. We'll change color actually. And I'm going to have a 0 when I've got 1, 0, 1. Oh, did I just put that? 1, 101, I did 0, and I've got a 0 when I've got, sorry, beg your pardon, misread the line, into 1, 0, 0, so 1, 0, 0. So I've got 2 zeros there. Okay, so that means everything else in that is ones. So circle the largest group possible. So I've got a circle there. Let's put that down first. So DC is equal to B, or we've got a group of 4 that we can do there, which is going to be not A. Okay, this one looks pretty straightforward. So 111 is going to be a 0. 001, 001 is going to be a 0. This one here, 101, 101 is going to be a 0. And finally, 011 is going to be 0. So everything else is 1. Oh, look at that. That's nice and easy. Circle all of those. So DB equals not C. Just very, very quickly, then doing the last one, popping them in. Like so. I end up with a big circle like that and a big circle like that. Now, in an exam, are you going to have to do all of them? No, you'll probably just have to do 1 or 2 of them. So we should end up with something like that if you were doing it. So hopefully you might pause the video or you might rewind. Okay, right, on the last one here. So last one here is I'm just taking that first example and I'm going to try and make it better. It's unlikely you're going to get one of these in the exam. So what we're saying is, if this is the main sequence, these are hopefully unused states. So if they're unused states, we don't care what they are, but we can use them to our advantage in doing the Kano map. So if I take DC to start with and pop the 1s in that I've got and the 0s, that is what I have. Okay, so these, I don't care what they are at the moment, but I can make them a 1 or a 0 depending on how it helps me. So if I was to then make these two that are 1s, I can then say, well, that there, DC is equal to not C. DC is equal to not C. And if I want to, I can pop that in now. So not C. So we end up with that would be a 1, that would be a 1, and that's a 0, and that's a 0. Just doing these two don't work out quite as nice. So we've got, that's what the information that we've got. So we've got some don't cares. Now we've got a number of options here. I'm going to say that I'm going to loop that one with that one, but I could quite easily wrap it around this way to that one, and this one here I'm going to loop around with that one. But I could, so I've got a number of options. So the Boolean algebra, I could do all kinds of things with the Boolean algebra. So DB is equal to not C and not B, or C and A. If I was to put that on here, I end up with that, and this DA in fact is going to be exactly the same. It looks exactly the same as it, so I'm going to go for exactly the same Boolean algebra on that. So I'm just long story short, I'm going to pop that in there like so. Now the good thing about this, hopefully, is if we've done this, and we can draw a diagram if we like, but hopefully we can do it by visual inspection. So state 4 was an unused state, it goes into 111. Is that part that does that feed into the main sequence? It does. So 010 goes into 100. That's part of the main sequence. 110 goes into 000, which is part of the main sequence, and 101 goes back into the main sequence as well. So all of our unused states now go back into the main sequence. So we've got no stuck states. So we've fixed it. Like I say, the chances of getting something like this in an exam pretty slim, but at least then I've shown you or reminded you how to do it. That's all I've got for the sequences, unless I think of anything else. If I do, then I'll put another sequencer video in place.